Welcome to the deep dive. It's really quite something watching how far language models have come.
Oh, absolutely. They seem almost, expert level in some areas.
Right, like in science, complex math. It's genuinely impressive.
But there's a catch, isn't there? The progress isn't exactly even.
No, not at all. People are calling it jagged intelligence, which feels pretty accurate.
Yeah, that term really captures it because you see these contrasts.
Exactly. Like a model might totally nail some super complex physics query,
Uh-huh.
but then ask it to, I don't know, count syllables reliably or just follow some simple writing rules.
And it falls flat sometimes.
Yeah.
There's that figure one, that shows it well.
Oh, yeah, that example's great. A top model struggling with just a couple of basic structural constraints in a sentence. It's kind of surprising.
It really highlights this gap. It suggests that while they're amazing as, let's say, pattern matching,
They maybe lack that deeper, more deliberate thinking.
precisely, that step-by-step careful reasoning, what psychologists sometimes call system two thinking.
Okay, system two. So moving beyond just predicting the next token and actually, well, thinking things through it.
Exactly. Building a chain of reasoning, evaluating options.
Right. And people have been trying to nudge models towards that already, haven't they? Like with chain of thought prompting.
Yes, chain of thought or COT has been a big one. Get the model to show its work, essentially,
Yeah, spell out the steps.
and that can help. But there are also these more structured approaches, things like tree search, borrowed from game AI.
Like AlphaGo searching moves.
Sort of, yeah,
Mm.
applying that idea. Or techniques like sequential Monte Carlo, more probabilistic methods.
Okay, so different ways to explore the possible solutions more systematically.
Uh-huh. But they have their own issues.
Right. Like code T can get really resource intensive, can it? And you can't always trust the thoughts.
That's a big one. It could be computationally costly. And yeah, the reasoning path isn't always sound. It might just rationalize a bad answer.
And the structured methods, what are the catches there?
Well, often you need to build specific components beforehand, like how do you score a partial solution or verify a step?
Ah, okay, so it requires more upfront engineering.
It can, yeah. And they often really depend on the model giving good initial suggestions. If the first few steps are way off,
The search might just get lost exploring a bad part of the solution space.
exactly, it can amplify early mistakes. So their scope can be a bit limited for really tricky or new problems.
Which brings us to this new framework. The source paper introduces DisCIPL. So how does this try to overcome those limitations?
So DisCIPL, which stands for disciplined meta-reasoning, takes a really different approach. The core idea is, well, it's meta-reasoning.
Meta reasoning, reasoning about reasoning.
Precisely. Instead of us telling the model how to reason with a fixed structure, DisCIPL lets the models figure out the structure themselves, dynamically, at inference time.
Okay, that sounds ambitious. How does that actually work?
The key piece is what they call the planner LM. This is usually a powerful model, like GPT-4o, in their experiments.
The brains of the operation.
Kind of, yeah. You give it the task, and it doesn't just try to solve it directly. Instead, it generates two things: a clear specification of what needs to be done.
Okay, like breaking down the requirements.
Exactly. And crucially, it also generates an inference procedure. Think of it like a custom-made computer program designed specifically to solve that task.
Wow, okay. It writes a program on the fly. That's the really novel part, isn't it?
That's the core innovation. Yes, it's not just a prompt, it's executable code that defines the reasoning steps, the checks, everything.
So what happens with this program? Does the planner run it?
The planner generates it, and then this program acts like a conductor, orchestrating other language models. These are called the follower LMs.
Followers. Okay, so maybe less powerful models.
Potentially, yes. And that's part of the point, as we'll see. The program calls these followers to do specific things.
Like what?
Two main things: generate text based on instructions in the program.
The generative mode.
Right. And evaluate text check if it meets criteria, score it, compare options, also based on instructions in the program.
The evaluative mode. Okay, so planner strategizes and writes the script. Followers execute specific scenes or review the takes.
That's a pretty good analogy, actually.
So what is the payoff? Why go through this planner follower setup?
It's about finding a better way to scale up the reasoning effort when you need it at test time. It tries to get the best of both worlds,
Meaning?
meaning you get the deliberate step-by-step nature you might see in chain of thought, because the planner's program enforces a structure.
So it ensures correctness, or at least adherence to the plan.
Exactly. But you also get the potential for parallel exploration, like in structured search, because the program can direct multiple followers to try different things simultaneously.
Ah, I see. So it's flexible parallel search guided by a custom plan. The planner ensures the how, the followers explore the what's in parallel.
You got it. That's the goal. More efficient and potentially more robust problem solving, especially for complex tasks.
Makes sense. So how did they test this? The source mentions two benchmarks, Kali and puzzles. What are they?
Right. Kali is designed to be tough. It focuses on constraint generation, making the model produce text that follows really specific, often complex rules.
Like format, content, relationships between things, stuff that LMs often mess up.
Exactly. It's a hard test of precision and following instructions.
And puzzle sounds more creative.
It is. It's a custom set they built with tasks that feel more like real-world creative reasoning. Things like writing poetry with specific rhyme and meter,
Okay, tricky.
or drafting grant proposals under tight constraints, making shopping lists that stick to a budget, planning travel itineraries, a real mix.
So a good range from rigid rules to more open-ended stuff. What models did they use for the planner and follower roles in these tests?
They used GPT-4o, a very capable model, as the planner.
Makes sense for the strategist role.
Right. And then, interestingly, for the follower, they used a much smaller model, Llama-3.2-1b.
Oh, okay. So a big capability gap between planner and follower.
Deliberately so. It lets them see how much the DisCIPL framework itself, the guidance from the planners program, can boost the smaller follower.
Smart. So what happened? Did DisCIPL actually help the little llama model punch above its weight?
Yeah, the results look pretty promising, actually. On tasks involving generating paragraphs, DisCIPL significantly closed the gap between the small follower and the big planner model's own performance.
Just by having that guided structure.
It seems so, and maybe even more impressively, on the really tough, constrained sentence tasks in Kali, and also across those puzzles tasks.
Yes.
The llama follower, guided by DisCIPL, didn't just get closer, it often outperformed the standalone GPT-4o planner.
Wow, really? The smaller model beat the larger one.
When guided by the program generated by the larger one, yes. And in some cases, its performance started to approach even more powerful reasoning models, like the reference to O1.
That is remarkable. It's not just about improving the follower, but potentially creating a combined system that's better than the planner alone for certain tasks.
Exactly. It really underlines the power of automating the inference strategy itself rather than just relying on raw model scale. The planner is essentially acting as an on-the-fly inference engineer.
Okay, so let's recap this deep dive on DisCIPL. The big idea is this meta-reasoning, right? A planner model generating custom programs
Programs that then orchestrate follower models.
to guide the reasoning process at test time. It's a different way to scale computation for complex tasks.
Exactly. And the findings show it works pretty well, especially for constrained generation, like in Kali, and these diverse reasoning covels.
We saw the follower model getting big boosts, often beating baseline approaches, even beating the planner itself sometimes.
Right. Significant gains, like you said, on sentence and paragraph tasks, poetry, budgeting puzzles, across the board, really.
And it wasn't just accuracy, was it? The outputs themselves got better.
Yes, that's a key point, too. They reported increased validity, meaning the outputs actually follow the rules much better.
Which is often the hard part.
Definitely. And also, improved coherency. The generated text just made more sense, was more fluent and logical.
So DisCIPL offers this automated way to kind of engineer the thinking process for a specific task. Less manual prompt fiddling, potentially more efficient use of compute.
That's the promise. It suggests we might be able to get more out of smaller, efficient models by guiding them intelligently instead of just building ever larger monolithic models.
Now, the paper also mentioned limitations and where this could go next. What are some interesting future directions?
Well, one obvious one is seeing how well this generalizes. Does DisCIPL work as well for, say, math problems, or tasks where you guide it with a reward signal instead of just constraints?
Makes sense, testing the boundaries.
Another area is exploring different types of algorithms within the programs the planner generates. Could it use things like backtracking search effectively, or maybe iterative editing and refinement loops?
Integrating other known reasoning techniques into this dynamic framework?
Exactly. And then there was that really intriguing idea of self-steering.
Ah, yes, where a single model plays both planner and follower.
Right. The idea that a model could recursively generate plans for itself, execute them, evaluate the results, and then refine its own approach, that opens up fascinating possibilities for self-improvement.
It really does. It almost feels like teaching the AI to structure its own thought process, which leads to a final thought, maybe. If LMs can start to self-orchestrate their reasoning like this, dynamically designing how they approach a problem, how does that change how we use them? What kind of new capabilities emerge when the AI isn't just following our prompts, but actively structuring its own path to a solution, maybe in ways we didn't expect? It's quite something to think about.
It definitely is. A really provocative question for the future of AI interaction.
Thanks for digging into this today. Fascinating stuff.
My pleasure. It was a great discussion.